Hey there, MSM3. We're starting Unit 3, and we're going to start with solving two-step equations. So what you'll notice is that I'll actually start with the one step, which we've done before, but for some of us, it's been a while. Solving an equation means that you need to find the solution to the equation or the value of a variable that makes it true. What is the solution to x plus 1 equals 8? Well, what number plus 1 will give us 8, right? And we can do that in our head, right? And say, well, x has to equal 7. Remember, it's an equation. It has an equal sign, meaning that your solution also needs to have an equal sign. Today, we'll be solving more complex two-step equations. To solve two-step equations, the first goal is to isolate the variable. Well, that's what we've done here, right? We get the variable by itself by using addition and subtraction or multiplication and division, which are inverse operations. We need to keep the equation balanced. Whatever you do to one side, you must do the same to the other. And we're going to use the reverse of order of operations. So whatever you would normally do last if you were evaluating an expression, that's what we do first. So we start by doing or undoing any subtraction or addition first. Solve the following equations. Show your work algebraically. So for example, on this one, I'm going to look at the side with the variable. I often use a highlighter and highlight the side with the variable. And now I'm going to look at what is being done to the variable itself. And right now I can see there's a plus 18. So I'm looking for any addition or subtraction first. The inverse of that would be to subtract 18 from both sides. And I would get 5 equals negative t. Now, if the opposite of t is 5, then t must just be negative 5. But what's really happening here is this is really a negative 1t. So I would divide both sides by negative 1 and get that negative 5 equals t. The negatives, right? Negative divided by negative is positive. And then my solution should always have the variable on the left. So t equals negative 5 would be my final answer. That's just a one-step equation that happens to have a negative, so it really acts like a two-step equation. H over 2 plus 7 equals 13. Again, I'm looking for any subtraction or addition first on the side with the variable. So I might highlight that side first and notice that it has a plus 7. The inverse of adding 7 is subtracting 7 from both sides. H over 2 equals, so 13 take away 7 would be 6. Now, still looking at the side with the variable, there is division, h divided by 2. The inverse of dividing by 2 is multiplying by 2. It's going to go right next to the fraction bar, not up, not down. And over on the other side, also multiply by 2. This multiply by 2 divided by 2 cancels, and h equals 12 is my final answer or solution. On the next one, same process. I'm going to identify the side that has the variable, look for any addition or subtraction. This has a subtract 12. So if I add 12 on the left, add 12 on the right, I get negative 7x. The minus 12 plus 12 would be worth 0 equals negative 16 plus 12. I have 4 more negatives than positives. And now this is almost going to look like I've done something wrong because over here I have negative 7x. This is multiplication, negative 7 times x. So the inverse is to divide by negative 7 on the left, divide by negative 7 on the right. X equals. Now, we all know that 4 does not evenly divide by 7. I can't even simplify that fraction, but I do know that a negative divided by a negative is positive, so I would leave my answer as 4/7 and be done. There's nothing wrong with an answer that's a fraction. It happens all the time. So the next one has an extra little piece to it. You notice that it's a subtraction problem and it's minus a negative 8. The first thing we're going to do is rewrite that. Negative 3x plus a positive 8 equals negative 28. The inverse of adding 8, because I'm looking at this side with the variable, would be to subtract 8 from both sides. Negative 3x, these cancel each other to be worth 0, equals negative 28 minus 8. If you want to write it out, if you want to rewrite it, negative 28 plus negative 8, you're saying I'm negative 28, like in the negatives, and I'm going to go down by 8 more. That's negative 36. Now, still looking at the side with the variable, negative 3x is multiplication. I'm going to divide the left side by negative 3, divide the right side by negative 3. X equals 12. You can always go back and check your answers as well. If you on this one were feeling uncomfortable with the minus and negative, or did I do negative 28 minus 8 correctly, you could plug that 12 back in. Negative 3 times 12 is negative 36, minus a negative 8. Well, negative 36 plus 8 is negative 28, and just check that it works. Now, the next one has a decimal. Actually has a lot of decimals, and I'm not a big fan of working with decimals. So one thing that I sometimes do if I notice that I'm working with a problem that has a lot of decimals is I get rid of the decimals as a first step. So you'll notice that this decimal has 2 decimal places, 0.39 or 39 hundredths. I can multiply both sides of this equation by the same number, and it's still going to be worth the same, right? That's the whole idea. So if I multiply the left side by 100, I get 39W plus 450 equals 840. And in each case, all I did was distribute the 100. I multiplied it by the first term, multiplied it by the second term, and I multiplied it by the term on the right. So this equation is worth the same. What's great about that is that now I'm not working with adding and subtracting and multiplying and dividing decimals. So if I subtract 450 on the left, subtract 450 on the right, I get 39W equals 390. Divide both sides by 39. W equals 10. And would I have gotten the same answer if I hadn't done that first step of multiplying both sides by 100? Sure would. I still would have gotten W equals 10, but my numbers were a lot friendlier to work with than adding, subtracting, multiplying, and dividing the decimals. All right, so the next one looks a little different because it has a fraction bar for division, has no addition or subtraction. So I'm going to start by looking at the side with the variable and saying what's happening to the variable. The divided by 5 with the fraction bar would get tackled first. So right next to the fraction bar, I would do times 5 and times 5. I would get 3x equals 10.2 times 5. Might need to do it over here on the side. 5 times 2 is 10, and then that's a 1, and that's a 5. Move my decimal point in one place for 51. And then I've got 3x, which is the side with the variable still. It's multiplication, so I would divide both sides by 3, and I would get x equals 17. Not terrible, just different. And then we've still got our squares and our square roots. So this will work the same way. We want to get rid of any addition or subtraction first, always looking at the side with the variable. So I want to get rid of that minus 10 with a plus 10 on both sides. X squared equals negative 81. And hopefully you already see this coming. If I square root both sides, the inverse of squaring is square rooting, I'm going to get x equals no real solution. Why? Cannot square root a negative number. Cannot square root that negative 81. Last one on the page, square root of x equals 14. Because the page has square root, I'm going to do the inverse, which is to square both sides. We talked about putting the whole side in parentheses, remembering to square both sides, not just one side. And we get x equals 14 squared is 196. Only one answer there. All right, so we're going to look at the back, which is some application, some real world stuff that goes with these two-step equations. So if you read this over, we're looking at an excavation from a cliff dwelling, and they found some bones. And we are going to use some formulas to predict how tall a person is from the length of a bone. So this is the formula for if we know the femur length of a male and we want to predict their overall height. And this is the formula for if we have the femur length of a bone for a female and we want to predict the overall height. So what does the F represent in the questions above? The F represents femur length. And in this case, it says it is in centimeters. So we would say femur length in centimeters. What does the H represent? We're looking to find the person's height. So H represents height, also in centimeters. Now, where did I get the centimeters from? I can see that there are centimeters here in the table. I can also see if I read up above that it does mention centimeters in the description. So look at the table above. For bone sample 1, find the height. So bone sample 1 is a male. So I'm going to first write the formula for a male height based on their femur length. And then I'm going to substitute what do I know about that. So we've got the femur length for the bone sample is 38.9. Now what's great about that is we're substituting it on the side with all of the other numbers. which means this is really simplifying an expression. We're just simplifying the right side of this equation. We would do multiplication first because we're not working on both sides. We're only working on one side of the equation. And so if we multiply those, we get 92.582. And then if we add in the extra 61.4, we get, it's approximately, because there's going to be a lot of decimals, approximately 154 centimeters. So we're saying based on the femur length of the bone sample found, we are predicting that that male is 154 centimeters tall. The second one that's there is for a female. It says Dr. Lashensky is 172 centimeters tall. Find Dr. Lashensky's femur length. Now, if we look up above, we would know that Dr. Lashensky is a female. And so we would first want to start with H equals 49.74 plus 2.59F. Choosing the right formula, obviously very important. And it says she is 172 centimeters tall. So over here, the height is going to be 172, and we replace the letter H with her height. And now we have an equation where the variable is on the right. So in this one, we have to solve on both sides because the variable is over here with the numbers. So I'm going to start by subtracting the 49.74 from both sides. And 72 take away, and I can do it over here if I need to. Is 122.26 equals 2.59F. So I first did either any subtraction or addition, and the 49.74 was being added to the term that has the variable. And now I have multiplication. So I'm going to divide both sides by 2.59 using my fraction bar. And I'm going to get F equals approximately 47. Now, Dr. Lashensky is alive, and so we can't just take her femur out. So we would say that we predict her femur is about 47 centimeters. So we can make a prediction about her femur. We could also make a prediction. He is about 154 centimeters tall. Now, if you are curious, that is around 60 inches. All right. Questions later, if you have them. Bye.